Hi, my name is Olusegun Rotimi Gabriel, and I welcome you to my YouTube channel where you have the opportunity to learn about detailed engineering design techniques for mostly rotating equipment and static equipment you come across in oil and gas industry and even FMCG industry. So if this is the first time you are coming across my YouTube channel, I would like you to click the subscribe button below so that you can always get notification whenever the new video tutorials are being uploaded. So click the subscribe button below in order to subscribe to this channel so that you can have access to some other videos that will be uploaded in the coming weeks. So for this session we are looking at what I title understanding pump friction head loss. Understanding pump friction head loss. If this is the first time you are joining us in this pump series, we've had some session in the past, so I have put the link in the description. You can check the description under this video, so you can always go and check that previous session before you listen to this particular session on friction head loss. So the question is, what do you mean by saying pump friction head loss? What is pump friction head loss? How do you calculate pump friction head loss? So that is what we are going to be looking at in this session. Now I want you to understand that by increasing the flow rates in your pumping system, this will introduce friction into the system as your liquid is traveling along the pipes from the suction tank to the pump and from the pump into the discharge pipe. So definitely there is going to be what? There's going to be friction into the system. So that's friction head, the friction head loss. The friction head in that your pumping system is the amount of energy loss due to friction of the fluid, of the liquid moving through pipes and what? Moving through pipes and fittings. So we are going to be looking at how do you determine that amount of energy loss due to friction for a particular pumping system. Now, the frictional head loss is determined as the sum of the fittings head loss and the straight run head loss. I repeat, your dynamic of frictional head loss is equal to the sum of the fittings head loss and the straight run head loss. So the question is, how do you obtain fittings head loss? How do you obtain straight run head loss? So we are going to be looking at these two in this session. So now, taking fittings head loss first. The fittings head loss is determined by this expression. Your HF equals your KV square over 2G. Your fittings head loss is calculated by what is known as K-value method, which is defined by this expression. Your K is the K-value method, is the K value. Your V is the superficial velocity expressed in meter per second. And your G is, of course, the acceleration due to gravity. So the fittings head loss is calculated by what I call the K-value method. Now, the question now is, what is K-value method? Now, for each type of valves, for each type of bends, for each type of tees, for any type of fittings you have in your pumping system, they have what? a characteristic resistance coefficient, or what is referred to as K value. You can see this in different piping books. For example, for 45-degree elbow, the K value is around 0.4. Same way for 90-degree elbow, can have K value is 1. And even some valves, the K value is 0.7. So to use this method of K value to obtain your fittings head loss, what you need to do is that you are going to count the number of fittings on the relevant suction or delivery line. You are going to count the number of valves on your P&ID. You are going to count the number of fittings in that particular pumping systems. Fittings such as your bends, your tilts, for the relevant suction or delivery line. So now, after you obtain the numbers of each of these fittings, you are going to multiply the number of each type of fittings by the corresponding K value. And what do you do next? You will add the K values for the various types of fittings to get your what? To get this your K. To get this K. And with your superficial velocity and acceleration due to gravity, you will obtain what we call fittings head loss. It is as simple as that. Now, don't forget that we said that your frictional head loss is the sum of the fittings head loss and the straight run head loss. Now, the fittings head loss is what you have obtained, with using K value method. Now, the next thing will be to determine what you call your straight run head loss. Now, the straight run head loss can be obtained from the Darcy-Weisbach equation, which states that for a pipe of uniform diameter D, the pressure loss due to viscous effects is proportional to the length and is characterized by this expression. Where you have your FD to be the friction factor. Your FD is friction factor, and this FD, which is the friction factor, is dependent on Reynolds number for that system. And the Reynolds number is expressed in terms of the product of the density of the fluid velocity, and the pipe internal diameter over the fluid dynamic viscosity. So depending on what your Reynolds number is, you are going to obtain the expression for the friction factor, so that you can put it in this expression to obtain your straight run head loss in form of what? In form of delta P, which is the pressure loss. Okay? Now your FD, don't forget, which is the friction factor. We said it is dependent on the Reynolds number. So for fluids with Reynolds number less than 2000, the flow behavior is considered to be a stable laminar fluid flow. So for that fluid system, the friction factor for the laminar flow is expressed as your FD equals to 64 over your Reynolds number. So if your Reynolds number is less than 2000, to obtain your friction factor, you just say 64 over what? Over your Reynolds number. So with this friction factor, you come back to this expression. You come back to the Darcy-Weisbach equation. You put the friction factor FD. You already know the density of the fluid. You have your fluid velocity, and then you have your pipe internal diameter, right? And then you have your what? You have your pipe length. All right? So that you can obtain your pressure loss, which in this case is going to be your straight run head loss. Now, if your fluid is now with Reynolds number, if you have fluids with Reynolds number greater than 4,000, we said the fluid is considered turbulent, isn't it? Now, to obtain your friction factor, which is your FD, you are going to use what we call the Colebrook-White approximation to estimate the Darcy friction factor, to estimate your FD for Reynolds number greater than 4,000. So you are going to obtain your FD with this expression, with your DH to be the hydraulic diameter of the pipe and your E to be the surface roughness of the pipe. So if once you obtain your FD, which is your friction factor for turbulent flow, you put your FD back into this expression to obtain your straight run head loss. So you've seen a case where you have for laminar flow or you have your turbulent flow. Now, same way for fluid with a Reynolds number between 2,000 and 4,000. They are considered unstable and so can exhibit either laminar or turbulent behavior. This region is commonly referred to as the critical zone, and the friction factor, that your FD, can actually be difficult to predict. So usually judgment should be used if accurate predictions of fluid loss are required in this region. So you can use either equation 1, which is this, which is for laminar flow, or you use equation 2, which is turbulent flow. So you can use either equation 1 or 2, for this critical zone to obtain your friction factor. So now, once you have obtained your fittings head loss and you've obtained your straight run head loss, so adding together the static head, depending whether your pumping system is a positive suction system or your pumping system is a negative suction system. So as long as you have determined your static head, so adding your static head, the fittings head loss and the straight run head loss will give the total head the pump needs to generate to overcome resistance and deliver the specified flow rate to the system. So this is how you obtain your frictional head loss in order to be able to determine the total head requirement for your pumping system. So this is the end of this session. So in the next video sessions, we are going to be looking at a real life scenarios where you will be doing a